In the focus of the program within the process is detailed process of production from the idea to final result under the brand Made in Kazakhstan. The program shows us an amazing world of projects, technologies and industrial developments.
It is definitely a discomfort when there is a power outage. As the sun sets outside, it gets darker in the apartments and houses. That means no TV, no computer or internet, and even the phone line is out. Nothing works. The boredom slowly sets in, and then all of a sudden, the power is back up. Did you know that electricity across the city is supplied by power stations? Thanks to them, we have light and hot water all year round, and in the cold winter time, during the heating season, we can always stay warm. However, how do the power stations generate heat and electricity? We decided to find out about the operations of a power plant and are ready to tell you all about it. Hello, you are watching the program Process, which tells you in detail about how it works. Today, our cameras are focused on the operational process of heat and electro power stations. One of the main ingredients used for the generation of heat and electric energy is coal. Freight wagons travel along the railroad, delivering coal right into the power plants. Straight from the tracks, the wagons are directed towards the rotary car dumper on which the wagon is rotated. The coal from the wagon is unloaded onto a conveyor belt, which moves it along. The coal from the wagon is unloaded onto a conveyor belt, which moves it along towards the furnace kettle. In the wintertime, daily on average 5 trains with 30 wagons, each loaded with coal, arrive at the power plant. That's 150 wagons per day. Every power plant has a storage house for coal, in which a supply that is sufficient for 20 days is stored, in the case of a disruption in the coal delivery system. This coal reserve is used up until the delivery system is back up and running at full capacity. Mazut fuel oil is used for firing up the coal. Storage basins with this liquid are set up on specially designed machinery, and the liquid is poured into the tanks. In order to make sure that the fuel oil is poured out effortlessly into the tanks, it is first heated up with steam. The steam raises the temperature in the basins, making the fuel oil more liquid. The second necessary component is water. However, water has a high content of salts and oxygen, which, upon the water's entry into the pipes, causes it to erode them. Therefore, there is an initial stage of chemical cleaning. Water is passed through filters as well as a deaerator, after which it comes out less hard and ready for further use. Coal is delivered into the boiler shop with the use of a conveyor belt. There, it is distributed among the raw coal bunkers, from which it is then supplied into the boiler furnace. From the bunkers, the coal is first delivered onto a grinding apparatus, a mill, and then moved to the furnace. A flow of hot air is also supplied into the furnace. To start the fire, a liquid fuel torch is used. Upon contact with the hot air, coal dust ignites. So here we are in the boiler shop. Where's the boiler furnace itself? Could you tell me where's the boiler furnace? Wait, this is it? I don't believe this. How about you? Could you tell me where the boiler furnace is? This really is it? Seriously? Well, as a matter of fact, this really is the furnace. The power plant houses huge furnaces. For example, this one is 42 meters high. How does it work? We're about to find out. The furnace that is set up at the power plant is a rectangular tank, the walls of which are screened with pipes along which water flows. Inside the furnace, coal is burnt, resulting in a flame. The water in the pipes gets hotter under the pressure and partially turns into steam. This steam, under the temperature of 540 to 560 degrees Celsius and under the pressure of 140 kilogram force per square centimeter, is delivered along the pipes to the turbine. Combustion gases resulting from the burning of coal pass through a special filtering device, an emulsifier. The purification rate of this apparatus is more than 90%. Therefore, the gases coming out of the pipes are clean. The heat and electricity generation process continues in the turbine department of the plant. Here, the steam turbines operate. Each turbine has a sensor installed, which allows to monitor its operation and adjust the workload. The turbine itself is closed off due to the high temperatures and high steam pressure. Steam is delivered along the pipes to the steam turbine. Heat energy is converted into mechanical energy rotating the turbine, which in turn is connected to a generator. At the speed of 3,000 rotations per minute, electric energy is generated. Part of the steam is used to heat up the water that is then pumped along the water pipes into the city. The remaining steam is cooled off in the condenser with the use of a circulating cooling water system. The steam is thus turned back into water, which is delivered to the initial stage of the entire cycle. All the operations of the power plants are automated. However, supervision is still required. Here at the main control switchboard, as well as the other more local switchboard, specialists work for whom the idea of responsibility carries a great weight. The safety and comfort of the entire city depend on them. Once the whole process of heat and electricity generation is completed, the process of distribution begins. Water with a temperature of 135 degrees Celsius is then delivered along the water grid system to end consumers. Electricity is distributed through an open distribution system, traveling along the cables and reaching our homes. Water which was used in the turbine cooling process is delivered to the cooling tower, a device for cooling water with the use of an atmosphere air stream. Water with a temperature of 35 to 40 degrees Celsius is delivered to the cooling tower. The tower has a ventilator installed which causes a constant motion of the water drops. While dripping back along the walls of the tower, water cools off to a temperature of 18 to 20 degrees, and then is returned to the process of cooling off the excess steam in the condenser. Only from the top of the cooling tower can one really see the massive size of the power plant. Its territory covers about 520 hectares, or about 860 football fields. This huge machinery operates non-stop, guaranteeing the supply of heat and electricity to our houses. The supply of heat and electricity is also uninterrupted 24/7. And you can bet that everything is set up here in a way that the power plant's operations do not cease under any circumstances. You are watching the program Process, in which we tell you in detail about how it works and thereby shift your perspective on things that surround us in our daily lives. My name is Nazar Mohamedjan. Until next time.